Heiner Lohmann. I'm Professor of Oceanography at the University of Rhode Island's Graduate School of Oceanography, and I lead a group of several graduate students, undergraduates and postdocs to look at the fate of organic pollutants. We look both in our estuary here, Narragansett Bay, and also in the Great Lakes and the different oceans.
I'm Carrie Pohl. I'm a graduate student here at the Graduate School of Oceanography at URI, and I study black carbon.
Hi, my name's Erin Markham. I'm a graduate student here at the Lohmann Lab at URI. And I think that the research that we do here is really important.
So the compounds we're concerned with measuring are called persistent organic pollutants, or POPs. And these compounds are persistent in the environment, which means that they don't break down easily. They also bioaccumulate, and what that means is that they accumulate in living things. This can be problematic because a lot of these compounds could be cancer-causing, and they cause other health problems. Some of them can cause neurological effects and hormonal disruption.
Our intention is to get a better understanding where the compounds are coming from, where they're moving to, and ultimately how they harm both the ecosystem and humans.
Persistent organic pollutants love to absorb to the black carbon, so it's actually a way to get them out of the environment. So it's important to study black carbon as a sink for some of these persistent organic pollutants.
Everyone knows that government organizations like EPA have these drinking water qualities and stuff like that, but a lot of what people might not think of is where this data comes from. And so it's really interesting to see the backstory of what we're doing here and learning about the nitty-gritty of persistent organic pollutants, why they're important, where they're coming from, and maybe with the data that some of our lab is putting out, it will help some regulations put in place for these newer chemicals coming out.
The same properties that allow these compounds to accumulate in living things also allow them to accumulate in other similar materials. One of those materials is plastic. So effectively, what we're doing with these polyethylene passive samplers is we're taking advantage of one of the properties of these compounds that make them problematic, and we're using that kind of to our advantage.
So we use these plastic sheets partially because they give us a direct measure of what is available to organisms. So it's a measure of bioavailability, and that's very important to understand if sediments or water are harmful. The other reason is that we can involve volunteers, so we can get much greater network coverage, and they're fairly cheap, so that's nice. Plus we can do a lot of small studies on the sites, like in our estuary, where we can just ask colleagues and friends to help us out and deploy them in marinas or in harbors or in their small brooks. So we get much different coverage, and that helps us again understand, are these compounds that we're interested in coming from direct emissions through wastewater plants, through rivers, or from industry, or are they just being recycled in the environment by coming back from the sediments or from some hotspots that are already existing. So that's generally why we like to use these kinds of samplers.
A perfect example of a persistent organic pollutant is DDT, which was a commonly used pesticide that was banned in the 70s because it was known to have harmful effects on the environment. And even though it was banned in the 70s, today in 2013, we can still measure it in pretty much any sample you give us.
So we partner with colleagues from Canada a lot to cover the Great Lakes, so Environment Canada, people from the Ontario Ministry of the Environment, and they deploy for us on the Canadian side. We work with people who do a lot of models, either of ocean atmosphere or processes, so those are either in the US or even in Europe. And internationally we collaborate with different scientists who help us deploy either on ship cruises or off land, so we get a good idea of where these compounds are moving on the bigger scale.
So once we've processed all of these samples and we have numbers for concentrations in the samplers, we can translate those to numbers in the environment. And then I can use those levels throughout the Great Lakes to pinpoint sources of contamination and figure out kind of how things are transported and where they end up. And we wouldn't be able to do any of this without all of our volunteers in the Great Lakes. So we're enormously thankful to them. We really appreciate their help, and we're always looking for more people who are eager to participate.